Okay. So this was supposed to be pretty easy. So which of the following, so the sketchpad was a video. How many people actually watched the video? Good. Good. Should have been really easy. So which of these did they have? Did it have direct manipulation of graphical objects? Yes, that was the kind of main thing. Scroll bars? No scroll bars. Scroll bars actually came in the Xerox Alto. We'll cover that later. Constraints? Yeah, that was one of the cool things. Rubber band lines? Yeah, they had that. WYSIWYG text editing? No, couldn't possibly have done that back in that day and age. Did they have a mouse pointing device? No, it was a pointing pointer, light pen pointer on the screen. Gesture recognition? No. And master copy graphics? They had that. So the next one is basically the whole point of my paper, and the answer is supposed to be false. So these are a bunch of different technologies. What's the oldest one of these? Sketchpad. Was Sketchpad. That's from Sketchpad was 1963. Amazingly long time ago. The next oldest one, SRI's NLS, which was from 68, 5 years later. The next one after that, whoops. Yeah, the Alto was 73. Okay. After that, the Star was 82. Then the Lisa, and then the Macintosh. And of course, the iPhone is from 2007. So if anybody got that one wrong, then you really don't know what you're talking about. Totally different, century from all the rest of this. Okay. So I'm going to be covering a bunch of these old systems and kind of what's important about them and kind of the context in which all these interaction techniques were invented. We're obviously going to start with the Sutherland system. Talk about the mouse and Xerox PARC, which was amazingly influential in inventing a lot of the interaction techniques that we all think are pretty commonplace. Then go into the Macintosh and to some extent Windows, although not too much. The handheld devices like the iPhone and tablets and so forth are going to be covered in a totally separate lecture, so I don't have anything about that here. And originally I had a whole bunch of stuff about the desktop and all of these other things, but it turns out there's a whole lecture just on that topic. So most of that will actually be covered later in lecture 6. And then, of course, Larry Tesler is giving a lecture about all the stuff he did. So only a little bit of that's in this lecture. Anybody ever seen one of these, a character terminal? So when I first started computing, this is kind of what I had to use. Basically, they were 24 lines long and 80 characters across, and each spot could only have a character in it. And eventually, you could do things like, vertical bars or horizontal bars or whatever. But basically, you just typed into different boxes. And originally, they only scrolled up and down like it was a piece of paper. But eventually, you could make the cursor go to a particular square and start drawing there. If you've ever typed command to Windows, you still get something that looks like this, or the console in Java, or they have the equivalent thing in the Macintosh or Linux. Still has this kind of old-fashioned character terminal. So this is kind of where everything came from. There weren't any interesting interaction techniques on these devices except for arrow keys. But it was kind of the context in which people started trying to invent things. So who knows what this is? Right. So there must be some double E's in the room, right? This is an oscilloscope. Anybody ever use one? A few people. So basically, there's this line that squiggles on the screen, and it's analog. It's basically showing you the signal that comes off of something. And the key point of it is that what we saw on the Sketchpad video is that the way that an oscilloscope works, which is how the screen on the Sketchpad system works, is that there's this beam that comes out of this tube, the cathode tube, and the beam is deflected by some computer-controlled or circuit-controlled magnets, and it bends the beam to go to a particular spot on the surface. And there's one in the x direction, one in the y direction, and so it can move the beam to any particular point on the surface of the monitor. And so the way that oscilloscopes work, which is the same as the way that the sketchpad system worked, is it actually makes the beam draw the picture that you want to see. Right? So if you wanted a box or a circle on the monitor, then the beam would go and draw the box, and then it would draw it again. Right? And so the reason that you see it flicker is that it draws it, and after it draws it, then it starts fading away. And your eye, of course, integrates, right, the picture. So even though if you took a really fast snapshot, there would only be one dot on at a time, because your eye smears it out and the phosphor actually smears it out a little bit, it fades away slowly. And so even though the beam keeps drawing this square over and over again, it looks to you like it's a solid square. So that was called, that was a CRT. And so what you see on the monitor in the video is that the computer is actually making the beam draw this shape over and over again. And the way the pointing device worked that he was holding, called the light pen, is that it was actually looking for that beam. It's actually like a little camera. It's looking for when that beam actually hit the camera. Right? So the beam would come through and it would hit the actual camera. So you could not point this at a black spot. It couldn't see the black spots. It could only see the points that were being drawn. And so that was called the light pen. It was the kind of only pointing device that was available back in these days, except for all these knobs and switches. And so he certainly didn't have a mouse or anything like that. He had this light pen. One of the problems with the light pen, of course, is you can't point at the black spots. Another problem, of course, is you have to hold your hand up in the air all the time, which is pretty tiring. So in the video, he uses some of these knobs for zooming and panning and stuff like that. He uses all these switches to do things, so kind of primitive interaction techniques for things like that. No menus or anything like that. He had this incredible array of switches that he was using to control things. But he did invent a lot of the important interaction techniques that we now take for granted. What we now call direct manipulation, which is when you have an object on the screen that you can directly point to it. Rubber band lines, constraint-based drawing, where it maintained the connectivity of things as you're moving them around. It was a while before those reappeared in graphics, so we had to do those all over again. This idea of prototype instance drawing is what we now call it, or master copy drawing, where he could modify the master and all the copies would update based on that. And he had, this arbitrary scaling of the entire diagram. They called it an infinite sheet, things like that. Of course, these incredible buttons and stuff is pretty awkward. That hasn't survived. No one does that anymore because it's too expensive and awkward and hard to remember because these buttons weren't really labeled. So he probably had a little piece of paper that would tell him which button did what activities. And then eventually, so the video had a bunch of people's work. It wasn't just Ivan Sutherland. So it talked about some of the 3D work, which was done after Ivan graduated. So this was Ivan's PhD thesis work at the Lincoln Labs. So other people did a 3D drawing system, including the hidden line elimination. And you could see some of the stuff was straining the speed of the processor that they had at the time, which was incredibly slow. So there was only certain stuff they could succeed at doing. And actually, the flow chart that they showed at the end, the graphical programming, was actually done by Ivan's little brother, William, who also went to MIT and got his PhD thesis doing the first graphical programming on the screen. So incredibly influential system. when I was in school, we were still using these kinds of displays. They were called vector displays because they were drawing lines, basically drawing vectors. And it was really the only way to have dynamic graphics at the time. Okay, so the next step is regular raster scan screens. So the difference between a raster scan is kind of like a regular TV. Probably people remember tube TVs, CRTs. So tubes, TVs don't draw the particular picture. That doesn't make any sense for a TV picture. Instead, the beam always draws the exact same pattern. It starts at the top, goes across the next line, goes across, and it draws all the lines of the show, and then starts back up at the top. And so the way that you get a picture is that the magnet is always making the beam go at the same pattern, but the beam itself is turned on and off, or turned to different levels, right? So if it's on and off, if it's what's called monochrome, either black or white, then the beam either goes on or off at each point. If it's grayscale, like black and white TVs, then at each point the beam is either on full or on half, or you could have different levels. And so that's how raster scan all CRTs work. Color TVs basically are the same thing, except the beam has to point at these little color dots. So if you take a magnifying glass and look at a color TV or a CRT screen, you'll see that there are actually all these little dots on the screen itself. And so, I'm not going to go into output or color theory or any of that kind of stuff, but every pixel are these three dots together, and it turns them on to the right level. LCDs turn out, instead of dots, to have little stripes. Same general idea, except that they're in stripes instead of dots. So if you take a magnifying glass up to your LCD screens, you can see that they actually have vertical lines of color. So how did the computer control these? So the idea that was invented in the Alto, and that was one of the reasons it was such a great boon for people to do research, was that we would take each pixel on the screen and use a bit of memory to represent that. Okay, and so the computer then, the software, could say, turn on this bit, turn on that bit, by just setting those bits to 1 instead of 0. And so the 1s were black and the 0s were white, pretty straightforward. At the time, everything was monochrome, so all you had to do was take your, I forgot to bring a pen again. You take your pixels and line them up basically take your computer memory and line it up sideways, and that would turn on the right bits. And then they had to do a whole bunch of hardware analog work so that it would look up which bits to turn on as the beam was scanning across. So that's about all I'm going to talk about output. Really not that relevant to this course, but it's kind of useful to know what this the big jump from vector screens to raster scan screens. So the next important innovation was SRI, and I'm pretty sure this was, I can't remember whether it was a bitmap terminal or character terminal, but they didn't really do much graphics. It was all about text. But the really cool things that he did in the demo were, first of all, they invented the mouse. He wanted an input device that he could use on the table. And what he's using in his other hand is a 5-button keypad with 5 different buttons. And one of the ideas that they had was with 5 buttons, 2 to the 5th is 32 different possible things. So his idea was that you would memorize the different chords for the different letters. And so he could type letters by putting different fingers down, and he wouldn't have to take your hand off the mouse. And so a few of the guys, not very many of them, basically Doug Engelbart, memorized all these different chords that you could use, and he became a fairly fast typist. Has anybody ever seen a court reporter? They actually use a corded keyboard as well. So, if you see all these dramas on TV and the court reporter's taking down what everybody says, they can actually type up to 300 or 400 words per minute, an incredible speed, because some people talk really fast, right? And so the idea is that regular typing isn't fast enough. And by chording, you can actually, with many fewer characters, get a lot more input. So, modern keyboard, except for the shift key, you never type two things at once on purpose. Whereas in chorded keyboards like this, or like the ones that court reporters use, you can go a lot faster. So his idea was, let's see how fast we can go. Let's make a computer really optimized for people. And so he invented the mouse for one hand and the keypad for the other. And the mouse was really successful, and the keypad was a dismal failure. So you kind of never know what's going to turn out. The other really cool thing about this demo, which isn't particularly relevant for this course, is that it was one of the first times that they showed two people working together on the same content. So it was the beginnings of what's now called computer-supported cooperative work, CSCW, where there was him and one monitor and the other guy in another room, and they were connected by some special phone wires, and they were both working on the same document together, and they could collaborate about it and talk about it and so forth. And to set up this demo at the 68 Fall Joint Computer Conference, they actually had to bring in a lot of special purpose hardware, and they had to get the phone company to run special purpose phone wires, and it was an enormous amount of infrastructure to set up for this demo, and it was kind of amazing that it all worked, but it did. The mouse he used was pretty primitive. Basically, it had two wheels mounted perpendicular to each other. So if you went this way, then one wheel would run, and if you went this way, the other wheel would run. And when you went perpendicular to a wheel, it wouldn't turn, right? So if I'm going this way, this wheel is just going to slide along the desk. And so using those two together, he was able to get motion anywhere in the plane of the desk. So that was the original idea. It turns out, if you actually look at this video, which I recommend, but I didn't assign, but it's still kind of fun to see, the user interface he's using is absolutely awful, right? So he has these totally bizarre commands that, like, do stuff on both sides of the cursor at the same time, and swap words, and all sorts of commands that never, we don't even use today because they're so useless and hard to imagine, what they're actually going to do. In fact, the engineers who built the system really never expected their user interface to be used by anybody, and they always expected somebody else to come on and put a decent user interface on their system, which kind of never happened. Doug and a few of the other people just kind of eventually memorized this terrible user interface and were able to use it pretty effectively. But they always admitted that it wasn't really their intention to use this user interface kind of for the future. So that was something that came later. So there's a great story, about in the textbook or in the book I assigned about how Xerox PARC came to be. But basically, there was a few people at Xerox. So Xerox, everyone knows, is a copier company. They make, and they were thinking, what are we going to do next besides just make copiers? And they had a very visionary management at the time who was thinking that computers were going to be relevant to offices of the future, and that they should try and figure out how they can make machines that go along with their copier machines that actually end up being part of the office of the future. And so they had this lab they built called Xerox PARC, and they were fortunate to be able to hire a whole bunch of people away from SRI, including Bill English, the inventor of the mouse, one of the inventors of the mouse, and a whole bunch of other PhD kind of people, many of whom went on to do other great things later, or did great things there. But it was, just an incredible collection of talent put together in this one place. And it's considered a big failure in the sense that a lot of their inventions, Xerox ended up not being able to make any money off of. But they did produce a bunch of things that Xerox did make a lot of money off of. So they invented workstations, which we'll talk about, but they also invented laser printing. So it's a way of computers, basically it's a computer-controlled copier machine, so it kind of makes sense that they would figure out how to do that. So normally on a copier there's this bar that goes down, you've probably noticed that. And so what's happening is the light is reflecting off the paper onto a selenium drum, which is getting excited in the places that are black and not so excited in the places that are white, or vice versa. I don't really know which is which. And then it passes over a tub of ink, and the parts that get excited attract the ink. I think that's right. And then that goes onto a piece of paper. And so there's this big drum in copier machines. And so basically that's how a regular copier works. And so what Xerox invented was this idea of, well, we'll have the computer, instead of having this light that goes across your paper document, we'll have the computer draw a laser beam, across the strip where the light would have been, and it'll turn on and off based on whether it should be black or white. So a pretty simple idea. They just were able to take their existing Xerox copier engines and turn them into laser printers. They had a whole bunch of patents all about this, and pretty much all of the laser printer companies had to pay license fees and so forth to Xerox for many years. And they made a really big business out of that. They also invented Ethernet. So that's the protocol that we all use for local area networking. So when you plug your home computer in, or when you plug a computer in at CMU and the computers are talking to each other, it's using the Ethernet protocol that Xerox PARC invented. They made a lot of money off of that. They didn't actually make hardware, but they licensed it to other companies like 3Com and other internet companies. And so the internet and laser printing made Xerox a lot of money. They also invented bitmap displays, which we'll talk about. And they invented enormous amounts of software and user interfaces, which they ended up not making any money off of. So that's kind of where this lack of success comes from. Some of the amazing things that they invented, besides the desktop that we're going to talk about in depth, they also invented object-oriented programming in the form of the Smalltalk environment. They invented the Model Q controller architecture. They actually invented what's now PostScript. A lot of the guys that went and formed Adobe were Xerox PARC employees, and they invented the precursor for what's now called PostScript, which is the language for the computer to talk to the printer, right? When you want to print something, there's this laser printer thing that's going to go on and off, but how does the computer tell the printer what to print? And one of the problems is that screens, even today, are 70 or 100 dots per inch. When you go to the movies, it says, Sony 5K or 4K or something like that. What that means is it's 4,000 dots per inch, right? Paper is 300 dots per inch. Printing has always been much higher resolution than screens, and projectors relatively low resolution. If you walk up here, you can see the little squares for the resolution of the monitor of the projector, and similarly on your laptop. But you can't see the little squares on printed paper. So the problem was you couldn't just take the picture on your screen and print it, because then it would be really low resolution. You could see the actual edges of all the characters, of all the lines and so forth. So the idea of Interpress and PostScript is that instead of saying put on this pixel, this pixel, this pixel, it says draw this curvy shape, or put an A there. And then it would go off and actually get a high resolution version of whatever it is you're trying to draw and print that. And so that's why printed documents look so much better than the documents on the screen. So some amazing things they did that didn't have anything necessarily to do with user interfaces. I'm happy to tell more stories about it, but it's really not relevant to the topic of the course. And much later, which we'll talk about in a future lecture, Xerox PARC. I mean, they had all this amazing stuff they did in the 70s. Then they didn't do much for a while. Then they had some really amazing stuff with visualization. And then in the 90s, they did a whole bunch of really cool stuff about ubiquitous computing and handheld devices, and they became really relevant again and did all sorts of very amazing innovations there, which they also end up never making any money off of. But it's, just incredible that this one lab has had such an enormous influence over user interfaces that we're all familiar with at lots of different levels. So here's the Alto. This is about the size of a small refrigerator or washing machine, a dishwasher. A dishwasher is probably the best closest. So it's pretty big, heavy. The disk, it had a hard disk that fit in this slot here. So it's a removable hard disk. It's kind of like a really giant floppy. It's about this big. It held like 1 meg. And the actual memory on the machine was very small. But for many, many years, it was understood that computers, Moore's law, computers were always getting faster. That was understood even way back here. And so the thought was, why don't we build a really expensive computer? This thing costs about $10,000. And we'll use it to figure out what everybody else is going to be using in 5 years, 10 years, whatever. Because by then, the computer that they'll get will be just as powerful as this one, but it'll be a lot cheaper. So that recognition that researchers should have machines that are really expensive, but kind of ahead of what the regular people could get, was a way that computer science research worked for many years up until the probably the 90s, when consumer products kind of caught up with research projects, and now it's not really possible for faculty to get more expensive computers than students or anything. So the idea was, it was called a personal workstation, kind of to differentiate it from PCs. So at the time there was an Apple II, right? So there were some little toy computers that people could get, but it was clear that this was nothing like that. And so they needed a different term. So these were called workstations. This particular computer didn't really have an operating system. So basically, every program that you ran took over the whole machine. So if I'm going to run Smalltalk, then I boot up Smalltalk, and the Smalltalk system runs. Or if I quit Smalltalk and I want to run my mail program, then basically it boots up the mail program, and that's all you're running. So it takes over the whole machine, the whole screen. And as a result, there's some low-level stuff like how to get to the disk and things that were shared, but otherwise everything was different. The original design used pretty much the same mouse design as from SRI, and it had 3 buttons oriented this way, called red, yellow, and blue, or red, yellow, and green. I think this one was green, but like a stoplight. This one shows it as blue. But they quickly got rid of that design. It was too expensive, and nobody could remember what the different buttons did. And they switched to 3 buttons in a horizontal array, so there was left, middle, right, and that's kind of the way we've done it ever since. And they also realized that instead of having these 2 rollers like on the other mouse, it would be more reliable to have 1 roller, 1 ball. And so that was pretty much the design that continued until we all got optical mice. So there would be a ball on the bottom, and there'd be some, inside the machine there was some sensors that would notice how the ball was rotating. The Alto, I actually was an intern at Xerox from 77 until 80, and the Alto was still a secret at that time. So everybody knew it was there. Lots of people had been to visit PARC, and they had said some things about it and so forth. But officially, Xerox claimed that the Alto was a secret. And so that was kind of weird. But eventually, Xerox said, OK, never mind. It's not a secret anymore. Everybody's heard about it already. And they actually loaned or gave devices to a bunch of universities, including CMU. So at kind of the end of its useful life, lots of researchers at universities got to play with them and do some pretty neat stuff. This is me back in '79. It happened over Christmas. I've gone home and found this in my dad's scrapbook that I sent him. So here I am sitting at an Alto at Xerox on the summer. That's the screen and the keyboard. And so we had these key sets that had come over from SRI. Nobody really used them, but they still made a bunch of them. Here's the 3-button mouse. And this is the Alto, and this one actually has 2 disk drives that, kind of like the ones we saw before, except there was one on top of another. So pretty enormous kind of device. Okay, so what was some of the software on the Alto? So one of the first things that people realized they needed was a text editor, and they built the world's first WYSIWYG text editor. It was called Bravo, and Butler Lamson, who's a famous systems guy, has anybody heard of him? I'm not sure what he's done that people would have heard of, but he really wasn't a user interface person. He was a systems programmer. He's currently works for Microsoft, but in between he worked for lots of different places. Charles Simoni was considered the chief designer of Bravo, and he's famous for having gone off after this and forming a little company that invented Microsoft, what eventually became Microsoft Word. Became really rich from having done that, being one of Microsoft's first employees, and has done a lot of weird stuff since then, like flying on the Russian spaceships and stuff like that. But Bravo was the first editor. It's from 1974. It had WYSIWYG text editing. That's what you see is what you get. Anybody heard of WYSIWYG? Everyone heard of that? Yeah. The general idea is that this was indented on the screen, and it would look kind of the same way on a piece of paper. I thought I had a picture of that. No, guess not. That you could have multiple fonts. Things were centered, lined up, all this kind of stuff. And so they invented a bunch of interaction techniques to let you actually, show things that way. Very different than the way we edit now. But, in terms of the way it looked on the screen, and it had 2 panes. So they realized fairly early that people like to compare documents to each other. And so it didn't have any kind of window manager or anything like that. But they have what we now call panes. So you could see one document and another document. And you could, move content from one to the other. They had a scroll bar. This cursor's in the scroll bar. And we'll talk about scroll bars in depth later. But basically, they had 3-button mouse. So 1 button went up, 1 button went down. And the middle button jumped to, the one you were at. Right? Pretty straightforward. Kind of an obvious design if you have 3 buttons and you want to go up, down, and jump. So that's what they did. Nothing like what we use today. They also had 3 buttons that they used for text. And so the left button selected a character, the middle button selected a word, and the right button extended. So again, quite different than what we're used to. And the commands in the editor were highly moded. So this is very similar to what people were used to for other kinds of systems. So if you hit a D, that would delete whatever was selected, right? Unless you were in insert mode, when if you hit a D, it would go into the text, right? So whatever the D on the keyboard did depended on what mode you were in, right? That's why it's called a moded user interface. And to get out of the mode, you hit the escape key on the keyboard, right? And so the idea was that if you wanted to start typing, you hit I, then you start typing something. Or if you wanted to delete something that was there, you could select some text and say replace, and then start typing its replacement, or delete, and it would just disappear, right? Pretty straightforward idea. Turns out there's a lot of issues with moded interfaces that people tended to mess things up. And there's this very classic thing that if you hit edit, what does that mean? Everything delete, insert T, right? And so you end up with, you had this great big document, and instead you end up with only the letter T on your screen, right? So everyone says, oh my God. So it turned out it was a pretty sophisticated system. It had an undo. But unlike today's undo, it only had a single level undo, right? So it only undid the very last command. So you said, oh my God, I just deleted everything. Let me get out of this mode. So you hit the escape key, you say undo, and that gives you back to a blank screen, right? Because the only thing it could undo was the insert, because that was the last command, right? And so this is kind of the issue with moded interfaces. Another really interesting thing about the Bravo that you can't see on this in this picture is that, remember I talked about how that there's a bit in memory for each pixel on the screen. So this was, I forget the resolution, but around 50,000 pixels, right? Let's see, it was about 700 by 1,000. So that's about 70,000 pixels. So that's 70,000 bits, which is what? 10,000 words, 10,000 bytes? Anyway, some reasonable number. It was really big for the time. And so one of the things that they realized was sometimes they needed more memory for the operating system or to do some algorithm or something like that. So all sorts of things would steal memory from the monitor. So if you were doing some work and it required some complicated algorithm, then all of a sudden the part of your screen that you could see started disappearing. And I remember specifically in Bravo that if you did something tricky like print, then all of a sudden sections of your document would disappear as it needed more and more memory to process whatever you're trying to do. And then when it finished that and it freed up the memory, then it would go back and use it for the monitor again. So it was basically, that was one of their innovations of this machine, was the memory for the monitor was the same as the memory for everything else. It was just a particular section that the hardware pointed to and said, this section is where you're supposed to display from. And you could say, oh, only this section, right? And then when you had enough memory, you would say, okay, use all this again. Another really important piece of software that was run on the Alto was Smalltalk. And this was Alan Kay. This is an old picture. He doesn't look like that anymore, just like I don't look like that anymore. We all had mustaches in the 70s. So Smalltalk was invented as an object-oriented programming environment. And Alan thought that it would be a great way to program for kids, to program interactive graphics and animations and kind of things, games, kind of things that would be motivating for kids. It turns out he also proposed the idea of overlapping windows. So you notice Bravo had these panes. Everybody else at the time was just dividing the computer screen. If you even look at the character terminals, I think the picture I had, right? They would divide it into sections, right? Vertically, that was pretty common. So this idea of vertical panes was pretty common. So Alan's idea was to use rectangles, which we now call windows, and he pretty much invented that in his PhD thesis at Stanford in '69. And so I have gone back and looked at this document, and it talks about how to do this, which is pretty amazing that it goes back that far. But the first real implementation of that was in Smalltalk 74, which he did at Xerox. And it also had pop-up menus and a bunch of other scroll bars, palettes, all sorts of things like that that are now pretty common, were first shown in the Smalltalk system. And if you read the document and the interview with Larry, he talks about how he invented the browser for code in Smalltalk a few years later. Eventually, Alan got Xerox to agree to release Smalltalk. And there was a big set of PR around Smalltalk 80. They released the implementation. They gave away the software for free and open source kind of thing. And there was a big article, lots of articles about it, and press and so forth. And it became enormously influential. I actually worked in Smalltalk at Xerox my first summer there in 1977. It kind of looked like this at the time. Used a lot of these interaction techniques way back then. And this, we'll be covering all these interaction techniques, in the various sections. So the way they did scroll bars and the way they did menus and all this stuff was pretty innovative. Also on the Alto were various drawing programs. Two most important were draw and markup. And the main thing that was interesting about these is they had totally different ideas for what the user interface might be like. And so, the Xerox people were exploring. There wasn't any standard at this time, right? Everybody was exploring new ways of doing stuff. So draw had this fixed palette. So different kinds of lines. Here's a big square, a circle, different sizes, different shapes. These are different selection things. There's text editing. And so, pretty much kind of what you'd expect in terms of a fixed palette of different size things to do. Whereas markup used everything as pop-up menus, kind of context menus. And they're a little weird compared to modern ones. When you press down, you only got a single row. And if the option you wanted wasn't in the row you were looking at, you would move your cursor up and down, and then the other rows would appear after that. So kind of a weird interaction. In terms of what it did, draw was, for drawing things, there's like, MacDraw or PowerPoint now, where these are objects you can select. Whereas markup was more like Photoshop. You're actually painting a picture, or Microsoft Paint. Of course, when I say painting, this is all monochrome. So every pixel is either black or white. That was the only choices. You couldn't get any grays. You couldn't get any reds. Everything's either black or white. Different fonts. So Larry, I'm not going to talk too much about him since we're going to have him tell us personally about how he, started doing this. But he got really, he recognized how really awful these modes were and how people really were making lots of mistakes. And so one of the things he was on basically a crusade against modes. And so this was his license plate, no modes. And he had T-shirts made, and he wrote a bunch of articles about how modes were bad. Of course, we have modes all the time in all interfaces, but kind of this concept that we should try and minimize them was really incredibly influential. And so he went about trying to figure out kind of less moded or non-moded ways of doing editing. So we're not going to do it in the modes like Bravo did it. How are we going to do it at all? So how are we going to do moving stuff? And at the time, he went and interviewed a bunch of people who were using real, who were newspaper people, real publishers. And the way that they did it was actually on pieces of paper. They would print stuff out and cut it with a scissors, and then rearrange it and paste it down with actual paste, right? And so that's actually where the words come from. Copy, cut, and paste are from using scissors and actual glue in order to rearrange things on pieces of paper. So he adapted those techniques as a way of, letting you do editing without having a mode. Of course, you kind of had this invisible mode of things being in the clipboard, but that was much better than the way that other systems worked. So he did this in the Gypsy editor that was kind of a standalone editor that was a replacement for Bravo that Xerox eventually demonstrated to lots of people, and it also was quickly added to Smalltalk for their text editing, and so the system that I used had Larry's copy-paste editing in it. He eventually recognized that Xerox was not going to do anything very creative with all of these things that he was inventing, and Steve Jobs, convinced him that Apple was, and so he left Xerox to go to Apple in 1980, and was basically the key person in charge of the Lisa design and eventually the Macintosh design. So he personally was kind of the manager of a lot of people and did a bunch of the work, a little of the work, but mostly it was other people. So meanwhile, this Alto that Xerox made was created for all these engineers, and eventually it got to be kind of well known that they were available, or you could create things like that. And so many companies sprang up to try and make workstations, kind of like the Alto, but aimed at engineers in general. So if you're a civil engineer and you're trying to design things, or some kind of scientist and you want to run studies, it would be cool to have your own machine, and maybe you can justify spending $30,000. Actually, I have 10, but I think they were more like 30. $30,000 on a machine just for you, because you can be so much more productive, and you're $100,000 employee anyway, might as well have a really expensive machine. And there were at least 4 major companies that were sprang up to do this. Sun, people have heard of Sun? Sun invented Java in the 90s, but way back in the 70s, Sun came out with a workstation. So it was a hardware company. And they were a spin-off from Stanford. Apollo, which probably nobody's heard of, was a spin-off from MIT, and they were in Boston. And then PERC, or Three Rivers Computer, it's the same company, was a spin-off of Carnegie Mellon. And I actually came here to work for Three Rivers Computer in 1980. And this was the computer that I worked on. It was called the PERC. It was a very sophisticated machine designed for engineers. It, was similar to the Alto. It had a mouse and a monitor and a keyboard. And for a long time, there was a lot of competition about which one of these would be the one to succeed. Eventually, everybody went bankrupt except for Sun, and then they went bankrupt too. Silicon Graphics was also making workstations, but they were specifically designed for being really fast for graphics. So in the 80s, everybody who was trying to do animation or graphics or fancy rendering for movies, everybody, all those people had Silicon Graphics machines. And eventually they went bankrupt too. But it's really hard to be in the hardware business. So Xerox did try and make a commercial product out of all of their research on the Alto, and that was the Xerox Star, which was released with quite a bit of fanfare in 1982. A lot of people heard about it, everyone heard about it, and nobody bought it. They had made a whole bunch of really interesting and not particularly correct in terms of marketing decisions. So first of all, they realized it was going to be an expensive machine, and they figured executives would never spend that amount of money for their secretaries. So they figured they better aim it at the managers themselves, at the executives themselves. So this was intended to be something that an executive would use themselves personally. And that was kind of a flop, because executives were used to telling somebody else to do their documents. Why should they spend the time to do their documents themselves when they could tell somebody else to do it? Nowadays, of course, everybody does their own stuff, but it was a very long time before that was common. Xerox kind of had the notion that the PARC people were all PhDs, wouldn't be the kind of people you would want to actually make a product. And so they hired a totally separate set of engineers and developers and hardware people to do the actual design of the Star. And so they were kind of inspired by all this work at PARC, but it was a totally different group of people. It was next door, actually. And my last year, when I was an intern, I got to walk down the hill and go take a look at what they were doing before the Star was released. It took a really long time to develop it, because they were trying to make a reasonable hardware, and they wanted to make this system really usable for lots of people, and so it was really quite challenging. The main thing that they provided was WYSIWYG text editing, drawings, and email, and then kind of code sharing, database stuff, kind of business things. Nothing like spreadsheets. That was kind of invented later and kind of independently. They had nothing like PowerPoint, because it wouldn't make any sense to make a presentation, because there's only one of these guys, and it's in your, in your office back at work. And another important difference is that it was pretty much a closed system. They pretty much assumed that all the software that a company would want, Xerox would make for them. Right? So it wasn't like the Macintosh where they said, or Windows where he said, we'll make a platform, you make a lot of software for it. They were trying to make it all themselves. So that was kind of surprising. Another thing, one of the things that killed it, besides the fact that it was really expensive, is that it seemed slow. Right? So you would push a button and you'd have to wait for something to happen. Right? And that's always really annoying. Now they wrote all these reports that said, if you're using our system, you're 3 times faster than you were with the old way of doing things, right? And so if you were doing a WYSIWYG document, then you could produce this document in 15 minutes and it would look exactly like you wanted, whereas in the old way, it would take you a half an hour or 45 minutes, or you couldn't even do it at all. But the problem was, even though overall you were more productive, you felt like you were being slowed down, because when you hit carriage return to go to here, it would take a while before the cursor would come back, or you would hit print and it would take a minute to actually generate the document and print it and things like that. So the hardware wasn't quite up to the level that people expected performance to be, and so that was pretty much of a problem. So there's this article that I recommended but didn't require you to read that talked about all of the user testing that they did. And basically they did, so the software development was pretty enormous for the time, 45 programmers for 3.5 years for 250,000 lines of code. That sounds like nothing today. Windows is, what, 20 million lines of code or something. But, obviously it was targeted at a much smaller machine, and they had to do the operating system and everything else. They ran 15 different user interface tests, formal tests of comparing different sort of things in order to decide stuff. One of the most interesting is that they decided that they would use a 2-button mouse instead of a 3-button mouse. And they did a whole bunch of tests of different text editing tasks, using a 3-button mouse or a 2-button mouse. They never thought of doing a 1-button mouse. That was just going to be too weird compared to what everybody was used to from the Alto, So they generally decided to use double-click, which is now something that everybody uses, but was kind of one of the inventions of the star, that a double-click would give you, word select. How many people know that you can double-click to select words? Yeah, some people don't know that. So in Word or PowerPoint or anything, if you double-click, it will select the word that you're pointing to. That was an invention that these guys came up with that Park had not had, because they had, an extra button to do that. And they also had lots of special keyboard keys. So there was a key on the keyboard that was labeled copy, and there was one that was labeled properties. So that kind of got you a dialog box that showed you the properties of things. And so they had a bunch of special purpose keys on the physical keyboard. Do I have a picture? Yeah. So these keys over here were, and I think these over here too, and these up here at the top. So they had all these special keys with labels on them that said different operations, and that's kind of how you did most of the things that you wanted to do. So there were many fewer menus on the screen, so, because all the menus were kind of on the keyboard. Okay. So, and there's a fun story in the book about how Apple ended up getting a lot of this technology, that Xerox had wanted to invest in Apple, that the executives at Xerox were thinking that, Apple is kind of copying their stuff. Maybe Xerox would buy Apple, and that way they would have this technology. But meanwhile, they wanted to invest in Apple's IPO. And so in exchange for letting them invest, Steve Jobs got permission to go and look at what they were doing at Xerox PARC and copy anything he wanted, which turned out to be quite a mistake from Xerox's point of view. So they had about an hour demo, a couple hours demo, and Steve and Bill Atkinson, who was his main programmer and designer, got to see all sorts of programs on the Alto in '79. And then, of course, they hired Larry Tesler and some of the other people away to come help do these designs. In particular, they saw the mouse, obviously. They saw Smalltalk with the overlapping windows. And there's a fun story that Bill Atkinson thought he saw the windows updating when they were behind other windows. And so he made that work in the Macintosh, where in fact, in Smalltalk, they never figured out how to make that work. In Smalltalk, if you wrote to a window that was covered, it would pop itself to the front before it would draw on it. Because it's kind of tricky if you're trying to draw on a window that's behind something, it has to clip out part and not draw through the window that's on top of it. That would look silly. So that was tricky to implement, and Atkinson, being a superstar programmer that he was, just figured out a way to do it very efficiently. They saw the WYSIWYG editing in Bravo, and obviously copied that in the original applications. So the Lisa came out, so it took them about 4 years from this demo until the Lisa came out. It was about a year after the Star had come out, and the design was, it was designed to be way cheaper, right? So if the Star was $10,000, this was, $1,000 or $2,000. I'm not sure how much it was when it originally came out. A lot of innovative features, a lot of designs that are different than the Star. Most people think it's kind of a direct copy, but really there was a lot of things that were done differently. The pull-down menus were obviously totally different. They had the concept of dialog boxes, which were different than Star's property sheets. Lots of other innovations as well. There's a one-button mouse instead of a two-button mouse, and it's kind of, Apple repeated that when they did the iPhone. They had one big button, right? One button at the bottom. The idea was that they wanted to build a computer that didn't require training. And they basically said, if you only have one button, then you can't click the wrong button, right? Whereas with the mouse that came with the Alto, people were always getting confused about whether they clicked the left button or the right button. That was, the key reason that they did it. And then they also had Larry's, non-moded interaction techniques that made it so that you could use menus on the screen and other techniques to do all the commands. And so you really only needed the one button for selection. And so they left that as the operation. That was very successful. And if you think about how we use buttons today, really the left button is selection and the right button is for menus and some other random things that could just as easily not be on a button. One of the things that really comes out if you read the book and some of the other stories about it was the enormous difficulty of getting this to work in a reasonable speed with this size, at the price point that they needed to achieve. A lot of it was written in assembly and really low-level code that was surprisingly efficient. They invented, new algorithms for drawing and so forth that let them do things quite quickly. So this is the original Macintosh from '84. It was much cheaper than the Lisa. It was a tiny, tiny screen, which caused many people to dismiss it as a toy. But really, Apple always knew that this was going to be the first in a line of computers and that they would make the monitors bigger as they could afford to. The original computer had no hard disk, so everything had to fit on one floppy, which was an amazing limitation. The operating system and your application, all had to be in memory at the same time. So in order to make that work, they took a lot of the things that they'd already designed for the Lisa and simplified them, re-implemented them in assembly language so they're much smaller, and did a whole bunch of other, throwing away of stuff that they didn't need. Have you guys seen the Super Bowl ad that introduced it? Anybody not see it? Want to see it? Okay, sure. Just a minute. Oh, I forgot the sound. Where's the sound? Oh, stop it.
see why 1984 won't be like 1984.
Of course, they're referring to the 1984 book, that predicted that 84 would be when we'd have a totalitarian government that would be monitoring us at all times, which we happily didn't have then, but may have now. At least it's not totalitarian. And it was directed by Ridley Scott, the famous director. So it was, amazingly influential. Everybody was aware of this, even if they thought it was a toy. That there was, enormous amounts of interest in the interactions that were being used on it. And so then they were trying to decide what to do next. Bill Atkinson wanted to try and enable people to program these things because, one of the things that was really important about the Macintosh, and the Lisa to a lesser extent, but definitely the Macintosh, that was very different than what everybody else was doing, was that when they released the Macintosh, soon after they released what was called the Macintosh Toolbox, which was a whole collection of basically widgets that let you implement things in the style of the Macintosh. And they also had something called the Macintosh Style Guide, which said, if you want to build an application for the Mac, here's how it should look, right? And no one had done that. In Windows, in the workstations that we were looking at, and in all previous computers, certainly in Alto, every application designed their own look and feel. Everything operated differently. It was only one of the key contributions to the Macintosh was they said, you have to do things the same way as everything else on the Macintosh. And here's how to do it. The left button does this. If you want to copy something, it has to be called the word copy. Here's how the menus look. And so this consistency, the idea that all applications work in a consistent way, that was really one of the key innovations of the Macintosh. But it was still very hard to program. And eventually they came out with more tools to make it slightly easier. But Bill wanted to try and enable the general public to write Macintosh programs. And so he invented this system called HyperCard. How many people have heard of HyperCard? Nobody? Okay. And, if Apple was a computer for the rest of us, then HyperCard was going to be programming for the rest of us. It didn't quite work out that way, but it was enormously influential. It invented a number of things that we are now using. It had this model of cards, and when you clicked on a new card, it would overlay the old card. So it's kind of what we do on the web now, right? So when you have a new page in the browser, it overlays, it goes on top of the old page on the browser. That was actually an invention of HyperCard. Other systems before that had popped up things in new windows, right? But there were a lot of advantages of reusing the same window. One of the ones is that you could use this to simulate an animation, right? So if you have a page and then you have a new page and you keep changing them quickly, then that can be an animation. So it was very important for that. It also invented the interaction technique of tearing off menus, like drawing palettes. So you would pop up a menu and then you could drag it off and use it. Some applications still do that today. That was invented for this. A few other things as well. So it was purely black and white. It turned out to be fairly expensive in terms of performance to have this system running. And Bill, for some reason, decided he did not want callouts to real code. And so he made it very hard to connect a HyperCard user interface with a real application written in regular, assembly language or Pascal or whatever. And so it ended up that people kind of only used this for prototyping. So in the same way as today, you might draw something up in Flash and then re-implement it for real, or in some other prototyping environment like Director. People that used HyperCard pretty much exclusively for prototyping at the time. So there were lots of great prototypes that were built this way. The programming language, this was one of the first programming languages that tried to be really English-like. You probably can't read this, but it says things like, ask password, get a new password. And so that would display get a new password. If it is empty, then exit mouse up. Put it into password. Ask password, please confirm your password. If it is empty, then exit mouse up. So you could kind of read this code as English, and it kind of made sense compared to C or some other language. So that wasn't a particularly helpful way of letting people program who weren't professional programmers. It turns out there are a lot of ambiguities in this language, like what is it refer to, right? And so as a programmer, you could say, suppose I have two things in the previous line. Which one of those is it, right? And you can think of all sorts of reasons why this language might be really ambiguous. And there are words like the that you can put in places. I don't see any here. So you could say, ask the password, and did that mean something different than leaving out the word the? And so they had optional words that got confusing and so forth. So it wasn't a particularly successful programming language, but it was a very influential system. And then I just have one slide about the PC, because, like I said, we're going to talk about desktops and stuff in the future. The PC as a piece of hardware, IBM had been what's called a mainframe company for many, many years, since the 40s, basically. How many people know what a mainframe is? Right? And so basically it's something a company would use in their back end to process billing and doing all sorts of the back end stuff that big companies need to do. And you would program these things by giving them these giant decks of cards, or basically say, do this, then spend as much time as you want on it, and then let me know what the answer is. After that came a phase of what were called mini computers, which are computers that typically were about the size of a full-size refrigerator. So one machine that was time sharing, and there was a company called Digital Equipment Corporation, or DEC. People heard of DEC? Nope. Based out of Boston, that was really big for a while, and eventually disappeared because so did mini computers. So IBM just completely missed the mini computer phase, which was the 70s and 80s, and decided to make sure that they didn't miss the microcomputer phase, which were personal computers. And so they came out with one in 81, which was really underpowered. At the time, the main competition was like the Apple II. And they used Microsoft DOS. And there's all sorts of stories, which I'm not going to go into, about how Microsoft got to be the operating system they used and stuff like that. There weren't any interaction techniques in that story, so I'm going to not talk about it. DOS, is a command line. It's like you still have the DOS prompt in Windows. Nothing much of interest there. Microsoft realized, after they saw the Star and the Macintosh and the Lisa, that they were going to need some kind of Windows product. And so they released Windows 1.0 in November of 85. It was kind of this DOS extension. And it was actually tiled. So this is a picture. You could only put Windows side by side. It turned out that the designer that they hired away from Xerox PARC, and of course everybody was hiring people away from Xerox PARC to do their work these days, because those are the people who knew how to do stuff. As we'll talk about in a few lectures, Xerox had invented a tiled window manager as well as an overlapping window manager. Remember, tiles is when you have panes, sections that don't overlap each other. So they decided to use that mechanism for their first window manager. That was a dismal failure. Nobody used Windows 1.0. So they went to overlapping 2 years later with Windows 2.0. Still wasn't very popular. Eventually, they changed it so that Windows was really an operating system. So the originals were just kind of plugins for DOS, but you still were kind of writing things in DOS, which was kind of an awful operating system. So Windows 3.0 was a real operating system. It introduced multiprocessing. It introduced protected memory, so things don't crash all the time. virtual memory so that you could have programs that were a reasonable size. So when they talk about Windows, even today, Windows 8, there's certain stuff that happens on the screen, but it's also all the stuff that happens behind the scenes, right? And so if you write code, you have to use the Windows way of accessing the disk and accessing memory and talking to the network. And so all the kinds of things that you do in code, talking to the screen, you use Windows for that. So Windows was always, and that's true of the Macintosh and all these other systems too, was always both the window system, the user interface, and the back-end stuff. And that really didn't happen until Windows 3 and around 90. 3.1 is the one that really took off in 92 when they got the bugs out. And kind of that's when Windows became kind of a mainline player with Windows 3.1 in 92. So it took them quite a long time to catch up. And Windows 95 was the one that first kind of had a reasonable user interface that everyone liked. And that's kind of was kind of the threshold point. If you look at the charts of, when things took off, Windows 95 was a real important point. Another thing that is really important about the PC is VisiCalc, which was the first spreadsheet. And Microsoft and Xerox PARC and Apple, none of them had come up with this concept of spreadsheets. But it turned out to be the most important piece of software for almost all businesses. And the people at PARC had no idea that that was going to be important. The Star had nothing like that. The original Macintosh didn't have anything like that. These guys, Bricklin and Dan Bricklin and I forget the other guy's name. Anybody remember? Who invented VisiCalc? Implemented it first on the Apple II, and then they invented it on the PC, and that really was one of the reasons that the PC became the business machine, is because you could do spreadsheets, and that's really what everybody wanted to do. So, it didn't really, at the beginning, have anything to do with, the cool icons and the interactions and using a mouse and all that stuff. It was all about being able to do your business kind of calculations. Okay, we have 1 minute left, so I wanted to talk just a quick second about the homework, which we haven't quite gotten up on the website. Let's see, oops. I wonder where, yeah, here it is. Okay, so I'm going to be posting this after the lecture. And the idea is that everybody's going to pick 2 devices. Remember we talked about this last time. Jeff has written this really cool software that runs on the web that allows you to tap. I guess I can probably try and run it. And let's see. So if we just go to Fitz Law, right? No. HTM. There we go. So you're going to type in your name, and you're going to test yourself. Remember, you have to test 3 people, someone, yourself, someone who's like you, and someone who's not like you. So you get to pick which one of those it is. Then what device? Let's call this a laptop. Let's call this an IBM laptop. And then I'm going to test the pointing stick. So that's a little red stick in the middle, so I'm only going to use that. And for the width and height, we want you to actually measure the screen in inches or centimeters, actually centimeters. So I'm not going to do that one, I'll do this one, right? So I would measure this and say it's, I don't know, I forget what my screen is. Let's call it 10 inches, which is about 25 centimeters. And the height, say 7 inches would be about 15 centimeters. So anyway, you have to get an actual ruler, or you can look it up on the web. So, what is the iPhone screen? You can look that up rather than having to measure it. And then the software calculates the right thing to do. And you should probably do all your devices horizontally, because what you get are these two bars. Okay, and you click on the blue bar. So I'm going to only use the pointing stick, and I move the cursor, and I click on the blue bar. And then I click on the other blue bar. And you go back and forth as fast as you can. Okay? And you'll see that you get different. If you get the right place, it turns green. And if I miss, it goes red. This one's doing the wrong one again. I guess I haven't installed the right software. And so it's about 4 times 4 times 20, or 320, is that right? 320 trials, so it's a little tedious. So when this little number down here gets to 20, then it'll change to a different size. Okay? And so the idea, so that's going to be a lot harder, right? When they're thinner, they're a lot harder, right? And when they're further apart, you would expect it to be slower as well, right? And so the idea is that suppose you did this with the touchpad built into your laptop versus a mouse. You know, which one do you think is faster, right? Suppose you did it on your phone with your finger, right? Then you might think that's going to be faster but less accurate, right? So getting something this tiny on a phone might be really hard to hit compared to a big fat one, right? And you know, you'll try laptops. So if anybody has an interesting input device, you know, a couple of people have the IBM laptop, you should definitely do the pointing stick because other people won't. So what we're hoping is that, and I'm going to put up this the class list as a Google Doc, and so everyone will enter the devices that they're using, and hopefully we can get a nice variety of devices. So don't everybody use an iPhone and their laptop, because that'll just be boring, right? So if you have, some people do a mouse, some people do a touchpad, some people, if you have an interesting Android phone that's a different size than everybody else's, if you have a Note or something unusual, definitely do that. You know, if you can do your game system at home or something interesting, you know, where you're pointing with a game controller, that would be fun. So we're hoping to get a few people doing interesting things. And then we're going to have you enter your information in the, into the system. So we're going to do a whole class summary, but mostly you're going to write a report about it. And in the next lecture, there's no lecture on Monday because of Martin Luther King Day. So a week from today, Jeff will be talking about, you know, how to do these studies. Yeah?
Device with the same physical size, resolution might be different, and different. Was that in the browser?
Right.
Firefox and Chrome would be differently, like the same web page.
Yeah, so one of the sections of your report, it's supposed to describe all that in detail. So everything about the environment in which you used, you know, which browser, what the screen resolution is. We didn't make you put it into the tool, but you definitely have to put all that in your report. Okay, any other questions? Okay, thank you. Have a great Martin Luther King Day.